I'd like to welcome you to meet Ivan Janicijevic. He's a senior software engineer in test, and he's passionate about building Android development and test infrastructure. He joined Google in 2006 and has worked on a few teams, including the Google Checkout team. He also helped the Google Wallet Android engineering team by building its internal development and build release systems. He's lived in San Francisco, just got back to New York about 3 weeks ago. And today he's working on mobile infrastructure for ads here in New York. So let's give him a warm welcome.
Thank you. Thanks. Hello, everybody. My name is Ivan Janicijevic, and I'm a senior SET here at the New York office. First, I want to welcome you to this amazing office. There's so many cool projects here in this office. There's so many cool people you can work with. There's so many cool things to play with. And the food is just amazing. Okay, so let me ask you a question. How many of you are Android developers? How many of you actually test your applications? Do you find it painful? Good. So, my team was responsible to make Android testing easier at Google. We developed the tools and infrastructure to make the building Android, developing Android, and testing Android easier at Google. And today's talk is going to be focusing on Android automation testing. And we're going to be talking on how to break the manual testing matrix. To set a stage for my presentation, I'm going to play this dramatic video.
I imagine that right now you're feeling a bit like Alice, tumbling down the rabbit hole.
You could say that.
I can see it in your eyes. You have the look of a man who is executing all these tests by hand now. Ironically, that's not far from the truth. Do you believe in manual testing, Neo?
No.
Why not?
Because I don't like the idea that people should do the same thing over and over.
I know exactly what you mean. Let me tell you why you're here. You're here because you know something. What you know, you can't explain, but you feel it. You felt it since 2006, that there's something wrong with mobile. You don't know what it is, but it's there. Like a splinter in your mind, driving you mad. It's this feeling that has brought you to me. Do you know what I'm talking about?
The manual testing matrix?
Do you want to know what it is? The testing matrix covers everything. It means testing on all phones, on every API level. Now even, it means testing on your glasses. Soon you'll have to test on your watch. You already need to test on TV. You need to test on cars. You need to test on different networks. It's the spreadsheet that has been pulled over your eyes to blind you on the truth.
What truth?
That you are a slave, Neo. Like everyone else, your manual tests are catching bugs that could have been caught with automation or emulation immediately. A prison for your mind. Your life is being wasted installing app on 100 different phones. You know you'll never prevent a regression. This is your last chance. After this, there is no turning back. You take the blue tablet. The story ends. You go home, test however you want. You take the red tablet. You stay at GTech. and I show you how deep the automation goes.
Okay. Hope you enjoyed the video. So I'm going to ask you to make a choice. Would you like to take the blue tablet or the red tablet? Red. Good. I have no slides for the blue tablet. So why automate? Let me put this in terms that everybody can understand. Just look at this function. This could actually be a Google interview question. Can somebody tell me what is the computational complexity of this function? Entry, yeah, yes. So let's look into this. We have tests. Tests are running on different devices. These devices could be Nexus 1, Nexus S, Nexus 7, 10, Razer Droid, many different devices that they keep adding new ones every day. Now, these devices might have different API levels. By API level, I mean different Android OS. It can be Froyo, Gingerbread, Gingerbread MR1, ICS, Jelly Bean, and so on. So you can see there's a combinatorial explosion here. We have full matrix of different devices running different API levels. This is how developer desktop might look like, Android developer desktop. As you can see, there's a bunch of phones lying around, lots of cables, generating lots of heat. But wait, there's something wrong with this picture. For each of the phones, we need to have different API levels. So for Nexus 7, we need to have one which runs Gingerbread, Froyo, Jelly Bean, ICS. So this pile is even actually bigger. Luckily, a typical developer uses only 1 or 2 phones on their desk, and they develop, they test on it, and there's some point where they need to test on a different phone, which they don't have. Then they're just going to scramble around, run the office, and scream, does anybody have Razer Droid? Does anybody have Nexus 10? So that I can test my feature on a different one. So automation is actually easy to parallelize. You just have tests running on different phones. It's the same tests running on different phones using different API levels. But why aren't we automating? What's the problem? Well, we have several problems to deal with. First, you need to have a place where you're going to run your tests. So you also need to have a device easily accessible under your fingertips. You might need to test it on a tablet or on a phone which has different density, and you need to have it easily accessible. And also, you need to make it fun and easy to write tests. Otherwise, you're going to meet lots of resistance. People are just going to give up and not write any tests. So this is written in developers.android.com. And it states, when building a mobile application, it is important that you always test your application on a real device before releasing it to users. This somehow gets twisted and turned around and boils down to this. We only do testing on real devices. Otherwise, we don't catch any bugs. Well, this is not necessarily true. So to do testing, we need to have a device lab. We need to have a place to run tests. So we have a choice. We can choose a data center hardware, which is gray and boring, but it's reliable, stable, it's standardized. It has a published data about mean time before failure, so you exactly know the time when to replace your hardware. And you have a good vendor support 24/7. On the other hand, you have consumer hardware. You have this Hello Kitty phone, which is very cute, very desirable, but that's not really reliable, especially when you run continuously 24/7. You bombard it with lots of tests, nonstop, and it's just going to give up at some point. It's meant to be used for about 6 months and then replaced with a newer model. And the support for it is just in your local mall where you actually bought a phone, it's just on a little kiosk. So it's not very good support for it. So you would think that Google has amazing device labs, but something that looks like this, maybe. So I'll show you the actual real lab, which I encountered about a couple of years ago. So here you see a bunch of Nexus S phones. They're actually glued to the wall with Velcro. And they use USB cables to connect to the USB hub, which is in turn connected to a desktop workstation. So this was great. It actually ran tests. It was actually mesmerizing. Sometimes I encounter people sitting there for hours looking at tests running. But then problems started happening. The USB cable gave up. The hub was having problems. The desktop just rebooted sometimes. And then in about a week or two, because we continuously running tests, the CPU heated up and melted the glue, and the phones started falling down one by one. Suddenly you get test failures. People start pulling their hair, so what's going on? It keeps failing. Yeah, I mean, it's really hard to manage this lab. You fight against gravity here. It's really tough. Well, the lesson is put them on the table, yes. So managing the physical lab has lots of problems. I mean, there's security. Somebody can just waltz in and steal your phone. There's maintenance. You have to replace the phones. There's new phones being issued. The phones die. All kinds of things happen to them. Then you have to upgrade the software on the phones. So you have hundreds of phones sitting there. How are you going to upgrade it? How are you going to manage it? How are you going to connect it to the proper hub? The hardware is also consumer-grade hardware. It's not a server hardware which is very stable. You have to rack it, you have to arrange it in small spaces, and they're all different sizes and shapes. Then they give up lots of heat. And we had lots of problems with signal interference. When you have Wi-Fi radio of 100 phones sitting in a small space, they keep disconnecting all the time, and you have these false failures. So is automation dead on arrival? How can we even test when you don't have anywhere to run their tests? Well, why are we so hung up on real phones? What are the most common bugs that you encounter? The class of bugs that you mostly encounter are concurrency and buffer overflows and off-by-one errors. Do they care on which device they run? No, these bugs are going to be reproducible on any device they do run. In addition to that, if you replicate the OS version, the screen size, the cache, and the memory constraints, we will probably catch 99% of the bugs. And we have the full matrix setup. There's still a chance there's a small set of bugs that can slip through, and they're usually very hardware specific, like Bluetooth or a secure element. But we can work around it by insulating the code around it and then testing it in insulation. This is actually a real Google data center. It's quite pretty. And we can run emulators in data centers. That means they run on a cloud. We can scale without any limits. Well, there's some limits, but it's quite large. These servers can handle lots of emulators. Can somebody tell me how many seconds are there in month of March? There's 2.6 seconds in March, in the month of March. And we managed to run about 82 million tests in March, so we can scale pretty good. We also have a reproducible test environment. We start fresh emulators which are in clean state, so there's nothing to contaminate from the previous run, and we have fully controlled test environment. What? That's ridiculous. You're going to test on emulators? That's not the real device. Actually, it's just another Android device. It emulates the real phone hardware, and the system images are almost identical. This is how the Android system architecture looks like. I'm not going to go deep into this. I just want to point out what is device specific. Can somebody tell me where do you usually find bugs in this diagram? Well, you don't find any bugs in this diagram. You find bugs in your application, actually. So we optimized the emulator. We created device specific device specifications for all the emulators for all the devices that we want to try to emulate. We took the RAM, the screen resolution, the screen density, and we also tweaked the operating system. Android emulators come with a rooted system, so you can easily change the product model to reflect to the real device name. And we installed some test-friendly services. These services allow you to create an account, take screenshots, dismiss the ANRs and system pop-ups that they're usually causing the flakiness for UI testing, and we log everything, not just the logcat. We do a system dump. We log everything that is loggable. That makes it easier when you debug the test failure. You can just go drill down, look at the logs, see the whole state of the emulator, and find the root cause of the bug. So how do I find the device that I want to use? I'm developing something. I want to test my feature. I have to dig it down in this pile and connect the right cable to the right phone. Is there a better way to do this? Well, it could look something like this. This is actually the emulators I was talking about. We developed a tool that you can launch any emulator that you want by just specifying in a command line saying launch Nexus 10 using Jelly Bean. And boom, in like 3 seconds, you would get the emulator there. You can install your APK, you can install your test, you can run tests, you can do whatever you want with your emulator. Emulator is just too slow. So this is the Android boot sequence. I remember the first time I installed Android SDK, I started running the emulator. It was blinking and said it's booting. I lost my patience after a couple of minutes and I just killed the process. I tried it again and the same thing happens. After several minutes, I got my Android running. Cool, it took some time. This is not very friendly. So if you look at this boot sequence, it's very similar to desktop. On desktop, we have something called Hibernate. On Android, we have something similar called Snapshot. So what we did, we just took a snapshot, and then we used that to boot. So we boot directly into Android, and that takes about 3 to 4 seconds. So what happens under the hood on the phone? On the left side, you have the phone. On the right side, you have the emulator. Emulator runs on the host hardware. Can somebody tell me what is the bottleneck here? Well, somebody draw the yellow rectangle to help you out. So in this case, in the case of Android emulator, it runs on host hardware, and we are emulating the ARM CPU. The CPU instructions are interpreted, and that's really slow. It's a software emulation. So what we did, we removed that bottleneck. We compiled Android with x86, and we are running that directly on the host hardware. The host hardware, you need to turn on the virtual machine to be able to emulate directly and run Android directly on the host hardware using the emulator. And this runs much faster. The host hardware is a much beefier machine than any Android device. This problem is solved. We reduced the boot time by using snapshots, and we are speeding up using virtual machine. So I created a little video that demonstrates the race between the real device and the emulator, running the same set of tests. This might be a little bit loud, so okay, same problem.
Gentlemen, start your engine!
and we have a winner. So we solved several pieces of the puzzle. We have a place where to run tests. We have any device we can bring up under your fingertips at any time that you need to do your development and testing. Cool. There's lots of work. We're done. We can go home, have a beer. It's only this. Don't be this guy. Listen to Jackie Chan. He's a wise guy. So unit testing on Android is different than typical web testing. In the web testing, we have it done pretty good. We use design patterns, either model view controller or model view presenter. We put most of the business logic in the presenter, and we test it in installation. While Vue doesn't have much logic, it's pretty lightweight. In Android, we have something called activity. Is activity a view or a presenter? Well, it's actually both. Activity contains both the view logic and the business logic of the presenter. So we are a little bit of disadvantage there for testing. Android's SDK provides a really nice tool called Android Instrumentation. And it's a nice layer on top of Android that allows you to do all kinds of wonderful things, like clicking on a screen in any location, sending key events, sending text, and also inspecting the state of your application and verifying what's going on the screen. However, it's very complicated to use. The API is not very friendly. So there are some efforts outside of Google, open source efforts. I have experience with Robotium that try to solve this problem by providing a simple API. We start using that and start running tests using Robotium, but after a while, our tests became very flaky, and they looked something like this. Our continuous build, which runs the test continuously, started to look something like this. Fail, 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 pass, fail, pass. And these failures are not genuine failures. Those are the fake failures. They're failures because of the flakiness. Matrix wins. Your testing is too hard. Let's just give up and go to the beach. That's it. Why are the tests so flaky? Well, in Android, we have a UI thread which runs the business logic. And then we have a test thread, which we request a click, which translates as a motion down in a UI thread, and then motion up. So some side effect happens meanwhile. And if you don't assert in the right time, we get a failure. We solve this by putting a sleep. OK, that works. But then in the future, something changes in the code, and our side effect changes the location. And then we again have a failure. So that's causing flakiness. So what if we could put all of this concurrency handling and synchronization under the hood and come up with something like this to help us run testing? We can then only focus on procedural testing. We can say, click on this view, and then verify if this text appeared. Well, earlier this year, my team got together, and we did a deep dive into Android OS, and we came up with a framework to give us something like this. We call it Espresso. Fortunately, it's not yet open sourced, and we are working on that. So hopefully it's going to become available sometime soon. So I would like to show you how does automated testing look like for us. Oh, of course. That's right. So we're not going to go into QA yet. I wanted to talk about, I want to show one more video later on. And remember earlier we mentioned there's some set of bugs that we cannot catch with emulators. And I had a chance to work on a Google Wallet project where we had a secure element which was stored on a phone. And one of the main features of Google Wallet is to be able to come down on the reader, go in the range of the reader, and then tap and pay, and then get out of it. So that was really hard to emulate. And I was thinking how to solve this problem. I came up with the idea to go and buy a little robot arm. I thought it was cool, so I did it in my free time kind of thing. I went to the local store, I bought this arm, which was about $35, and it had a USB connector. I wrote a little driver for it, and it was very simple. It was just saying, turn this motor on for 1 second, and turn this other motor for 2 seconds, and that was it. And it was great. I mean, I can solve this problem. So I tried it out. It was going down and up, and it was actually working. But if I did it like 20 times, it went out of alignment. So I started hitting the desk. I was like, crap, it was a great idea. It's not going to work. I went home. I was taking a shower. And I was like, hey, the phone actually has a gyroscope. It's a very precise instrument. I can use that to tell me what is the angle of the phone. So I was like, cool. I'm going to try it out. So I wrote a little app to tell me what is my angle. And then I hooked it up, and I made it work. So I'm going to show you the video of that. That's a duct tape right there.
You're charging power battery and all your thermal energy. We are the robots. We are the robots. We are the robots. We are the robots. We're functioning automatic. And we are building mechanic.
Skip a little bit, it's very long. This is the angle, but this is what the phone sees actually. Do you want more? Okay. Now we can move into questions. Yes? So the ROMs are, we are testing only in the Google Experience phones, and we cannot get manufacturer-specific ROMs. But I think most of the bugs should be covered by testing the Google Experience phones, unless something drastically is changed in the manufacturer ROMs. It's possible. Yes?
Are those going to also be available on Eclipse, or is it only specific for Google?
So those emulators are available on Eclipse. Those are the same emulators we use, the same images. You have x86 images that you can use from Eclipse. What we did some additional modifications to the emulators to make it more friendly for Google developers. And it's like installing, setting up the accounts, changing the memory, tweaking the memory, RAM size, density. That's all available. You can just go and do it yourself.
Hey, how's it going? So we actually moved away from emulators back in 15 because we saw a problem with them crashing. We would try to run our tests and then they would crash. So this became a problem. How do you guys deal with that sort of flakiness? Or has that stopped becoming a problem? Because we never actually used snapshots.
So we actually optimized our emulators and we made sure that they're not crashing. We didn't have any problems with crashing. Do you know any reason why they were crashing?
We have no idea.
Have you been using x86 emulators or?
Yeah, we're using x86 on Ubuntu boxes. So not sure why.
So they were really slow.
Yeah. So maybe it's the hardware that you're running on. I'm not sure. Try using different hardware.
Try different hardware. Sounds good.
Yeah. It's a very specific question. It's hard to tell what was the reason for the crash.
So I'm actually curious. So how much manual testing do you guys do, if any?
That's a good question. I think manual testers are very precious, and we should use them preciously, right? We should do most of our testing using emulators, doing unit testing, and trying to automate as much as possible. And just let our manual testers do real testing, exploratory testing, creative testing, versus trying to go and execute a big matrix of list of things and checking the boxes. Because they're going to be testing it as a real users, and that adds real value then. Could you walk up to the microphone, please?
One of your remarks, it sounds like you expect the developers to test themselves. Is that how you work, or do you have a separate QA group or a separate testing group?
That's a good question. At Google, part of your job as a developer is to write tests. So it's your job. It's test-driven development, so you have to write tests before submitting. You shouldn't be submitting your code in repository without writing any tests. And these tests have to pass before submitting it in. That way, we ensure we have quality ahead revision. We have somebody in the back there.
Give us an idea of what a typical test suite would look like for any arbitrary project or piece of code that you're about to test. What's the life cycle of developing the tests and then the effort that it actually is involved given the support that you outlined?
Good question. We have a philosophy at Google which is distributing tests into small, medium, and large. And that's the rule is about 70, 20, 10. So 70% of your tests should be unit tests, a small, very, very small tests, which execute really fast, and they're not dependent on any UI or anything large. They shouldn't be talking to the network. They should be focusing only on your function. Then you have medium tests, which exercise testing between different components, and you have large tests, which are end-to-end tests, which exercise the whole system. So that's pretty much the philosophy that we go by when we design tests. Most of them are very small, and then only 10% should be large.
So the complexity hasn't changed, though. You still multiply the number of tests by the number of platforms to get the full coverage, right?
Yes.
And yes, you can get more tests running at the same time on a host than you can on a consumer electronics device.
Yes.
Okay. But as you keep adding more devices and you keep adding more tests, how rapidly are the respective sizes growing, the amount of work you have to do and the power you have to do the tests?
Yes, so we can scale very well in our data centers. So right now, there's no concern about running out of processor time or space in our data centers. But you're right, the matrix is expanding, it's growing. But we also look at the usage of different older operating systems. For example, Donut is not really used that much anymore. So we might decide at one point to drop it and reduce the tests that way. Yes, of course.
So known perception that you don't expect programs to be as fast on Android as other platforms. I don't know if you agree or not, but it's kind of an expectation. So you try to test as soon as possible on Android for the performance. So you didn't mention anything about that. For you, the test is failing if the program does something unexpected, right?
Yes.
But this, the perceptional parts of it are not really part of the discussion. But to the testers, that is a problem, especially if you're doing something really intense graphically. But even if it's a business application, if it's like jerking around, you're behind your competition potentially, and you don't know it until you test on that device.
Yes.
That brings back the problem of testing on an emulator. Sometimes it's faster than the real device, sometimes it's slower. You can't predict this. Well, okay, but suppose you do say, okay, I want to test on my emulators only, but still, how do you test the performance aspect of that programmatically?
That's a very good question. Performance is, you mostly test the logic on emulators. That's the primary goal. Performance, you can put in some kind of instrumentation and try to test the performance and optimize it on the emulator itself. But it's not going to guarantee that it's going to run the same way on the device. And it's a whole different set of problems that you have to deal with when it comes to the performance testing. I guess you can still improve your application using emulators and make sure it's optimized there, and it has a good chance running better on the real device. But it doesn't really help you much running on emulator. It's not going to give you the real information. That's true.
Do you guys have plans to provide testing infrastructure as something like cloud service, maybe, in the future?
We definitely play with this idea. It's honestly, it's lots of work, and it might be possible in the future. We're discussing this. I can't tell you that it's going to happen anytime soon, but it's possible. And I think it's a wonderful idea.
The application that we're testing uses embedded YouTube videos. And in the past, the emulator hasn't done so well with playing video in automation.
Yes.
Has it improved, and how do you handle video testing in-house?
Yes, very good question. We did enable OpenGL emulation on emulators. So if you have the host machine which has a GPU, it's possible to run OpenGL and actually have the GPU acceleration. In that case, the videos would work fine. If you have the set of hardware, in your data center, if you have a set of servers which don't have GPU, then you're going to have troubles. But you can still go around it by using MESA drivers, which is a software video driver emulation. It's going to be slower, but it's still going to achieve the effect of testing your video. Yes. So think of it as emulator being the real device. So it actually operates as a real device. Do you have any specifics on which? Oh yeah, you can run anything as you can run on real device. As far as the OS is concerned, it's the same. It's running on device. It doesn't know it's running on emulator. Oh, we're just trying to pretend that we are that specific device. Let's say Nexus S has, I don't know exact number, but it's 64K cache, and it has 512 memory. So we make sure that our emulator has the same constraints, RAM constraints. So if your application runs out of memory in the Nexus S, it will also run out of memory on the emulator. Yeah, that's a good question. That probably falls in the category of this 1% that we can't test on emulators. The way to go around it is to take your code which interfaces with sensors, insulate it, and then test it thoroughly in insulation. And then probably have some kind of manual validation on the end of the day. But most of the bugs you're going to catch in the software emulation. So you're going to have to do minimal work with the real hardware at that point.
Does it also include orientation changes?
Yes, you can. One of the features of our test services, we also added the ability to change the orientation, which has the effect of redrawing the application. Yes. Yes, because you're not on the microphone, I'm going to repeat the question. Do the emulators reflect the Sense UI, the third party, the ROM producers' modifications? No, we just use the Google Experience phones. So we don't, and there's a slight possibility that something might not work as expected there, because we don't have the images. They're proprietary.
How do you approach testing inside the browser across the family of like front end or I've always sort of wondered, how do you actually get a handle on testing when all you really have are 3 or 4 codes and there's actually hundreds out there?
Yes. Again, you should use emulators. So there's something called WebDriver that you commonly use to test the web applications. And you can use the same WebDriver implementations for there's a WebDriver implementation for Android native browser that happens to be the same as a WebView. WebView is using Android native driver implementation. And also other browsers for Android like Chrome and I don't know, maybe Opera, they should have their own implementation for WebDriver. They might not, but it's their responsibility to implement the WebDriver spec. And then you can use the WebDriver API to drive your testing on the web page of the Android. Yes.
I have another question. So we actually used Robotium in our project a little bit ago, and we had some experiences in terms of the flakiness. And we recently switched to the UI Automator, which was released by Google with Jelly Bean. Do you have any comments about it? Because you mentioned that you were working on your own gig Espresso. So is there any particular reason?
So it's a little bit different. UI automators try to approach the problem from a different angle. They're using the accessibility framework, and they don't actually have the access to the context of the application. So they can just click around, but you don't actually know what happened underneath. You can't query, you can't change the state of the application, and it's not using instrumentation, right? The approach that we took is to use the instrumentation to drive the testing. So, I mean, there's overlap, but again, you can use both to solve different problems. And it's less flaky, definitely. Good. More questions? Okay. Well, thank you.